All right, and welcome to Absolute Value Level 2. Now, number one, we want to find the solutions to the function f of x is equal to the absolute value of x, close the absolute value bars, minus 3, where f of x is equal to 2. Now, just showing you what this looks like graphically, we see here that I'm drawing this line through there, and we are trying to find out where are the solutions to this. And we could actually do this just looking in the graph. Clearly, this is 5, and clearly this is negative 5. However, how would you solve this algebraically? Well, we know f of x is 2, so we'll write 2 is equal to the absolute value of x minus 3. And wait a second, here the absolute value bars are not by themselves. We can't immediately set this problem equal to positive 2 and negative 2. We have to get this problem where the absolute value bars are by themselves. So we'll add 3 to both sides. We'll add 3 to both sides. We'll get 5 is equal to the absolute value of x. Now you should remember from the intro to absolute value, well, this is very clearly saying that x is equal to negative 5 or positive 5. And so this is just a really, really simple example. But what's your key takeaway? You have to get the absolute value bars by themselves. Let's move on to example 2. Okay, for example 2, find the solutions to the function f of x is equal to 3 over 2 absolute value bars of x, where f of x is equal to 6. Now notice 6 is actually off the graph here. We could probably make a prediction, and maybe it's going to be at negative 4, and maybe it's going to be at positive 4. Those are just kind of my predictions, judging from where it looks like the graph is headed. But let's go ahead and plug it in. So f of x is 6, so we can write 6 is equal to 3 over 2 absolute value bars of x. Now remember, we cannot solve this problem until we get the absolute value bars by themselves. Now instead of dividing, because these things are being multiplied, instead of dividing by a fraction, remember our rule is that when involving fractions, let's just multiply by the reciprocal. The reciprocal of 3 over 2 flipped is 2 over 3, and those reduce to 1. Now I multiply the left side by 2 over 3, and what do we really get here? Well, remember our rules of fractions. We change 6 into 6 over 1, and we multiply top by top. 2 times 6 will, of course, be 12 over 3 times 1 is 3 is equal to the absolute value of x. By the way, we can simplify this. We know that 12 over 3 is actually equal to 4, is equal to the absolute value of x. And now that we have the absolute value bars by themselves, we can simply say x is equal to negative 4 or positive 4. And it looks like my predictions were pretty spot on. All right, let's move on to our third and final example. Okay, for example 3, we want to find the solutions to the function f of x is equal to 2 absolute value of x, close the absolute value, minus 3, where f of x is equal to positive 1. Now notice if I just draw a line through positive 1 on the y-axis, we can already get a sneak peek. Our solutions should be negative 2 and positive 2. However, let's make sure that that holds true. And so we can put 1 in for f of x. And now we have to solve this to get these absolute value bars by themselves. Remember, what do we get rid of first, the multiplication or the subtraction? Well, in basic solving, we get rid of the subtraction first. We'll add 3 to both sides. 1 plus 3 is 4 is equal to 2 absolute value bars of x. We know we'll divide both sides by 2, and 4 divided by 2 is equal to 2 equals the absolute value of x. And of course here, well, we would say that x is equal to negative 2 or positive 2. And it looks like our solutions check out again. All right, thanks guys, and I'll see you guys in our very next lesson.